All right, guys, so in this video, we're going to continue working with parabolas. Most of this is review, but we're just going to throw some harder questions at you. So remember that the standard form of a quadratic function follows this format. If you have the format y equals ax squared plus bx plus c, that is the equation for a parabola. If you see something that looks like this, it's going to be either a smiley or a frowny. Okay. And if you're in this standard form format, you're going to be able to pull out some of the key pieces of information relatively easily. Okay, whenever you graph a parabola, the first thing I want you to find is the axis of symmetry. And remember, the axis of symmetry always follows the format. X equals negative b over 2a, whatever those two numbers are. Plug them into the formula, and it should be a straight up and down line at that number. Your vertex, it's going to be one of two things. It's either the bottom of the smiley or the top of the frowny. Okay, the vertex is going to be, it's going to have an x and a y coordinate. Your x coordinate is always going to be whatever number you got right here, negative b over 2a. And then your y coordinate is going to be whatever number you get back after you plug this number into the equation. So the fancy way to write that would be f of negative b over 2a. Okay, so basically, take this number, plug it into your equation, and you'll have your x and your y coordinate. You're going to be able to tell what your parabola looks like just by the equation that they give you. If a is a positive number, if the first number in front of your x squared term is a positive number, it's going to, your parabola is going to open up. What does that mean? If your a value is positive, it's going to be a smiley. It's going to look something like that. But if it's the opposite, if a is a negative number, it's going to open down. It's going to be a frowny. What's an easy way to remember this? What do positive people do? They smile. What do negative people do? They frown. If a is positive, it's a smile. If a is negative, it's a frown. And then your y-intercept, the place where your parabola always crosses the y-axis, is always going to be the coordinates 0, comma, c. Whatever your c value is equal to represents your y-intercept if you are in standard form. Okay, a couple other things. We're going to start talking about domain and range. Whenever you see the word domain, what do you think? You're thinking of x, okay? But more specifically, the domain is the set of inputs. Another way of saying x values. Domain is x, and then the range is y. Range is the set of outputs, or y values. When you think domain, you're thinking, what am I allowed to plug into this equation? When you think outputs, or when you think range, think what are you able to get back? All right, so we're going to do example 1 together here. It says find the axis of symmetry, the vertex, the y-intercept, and graph the quadratic function below. And it says also state the domain and range of each function. Okay, the order is intentional here because the first thing I always want you to do when you're doing these types of questions is find the axis of symmetry, the AOS. Every single time, for the sake of this class, your axis of symmetry is going to be in the format x equals negative b over 2a. It's always a good idea to identify what a, b, and c are equal to at the start of the question. So a is the first number, b is the second number, c is the last number. So based on the equation we're seeing right here, a should be equal to negative 2, b should be equal to 4, and then c should be equal to negative 5. Please make sure you're paying attention to the symbols in front of it. That's a minus sign, so this is a negative 5 for c. Okay, once you have that, it's a pretty straightforward plug and chug and simplify. Your numerator is negative b, so instead of positive 4, it's going to be negative 4. And your denominator is going to be 2 times a. 2 times, it looks like it's negative 2. Simplify this a little bit. It should be negative 4 over negative 4. Negatives cancel, and you should be left with x is equal to 1. Okay, as soon as you get your axis of symmetry, it is a good idea to sketch it as a dotted line on your graph. Your axis of symmetry that cuts the parabola in half is going to be right here, at positive 1. Okay, so we got the first step down. We've got the axis of symmetry. Now what we're going to do is we're going to get the vertex. And if you have the axis of symmetry, it makes finding your vertex a little bit easier. remember it's always an x and a y coordinate. Your x coordinate is just going to be whatever that number was. For the AOS, in this case it's 1. Then to get your y coordinate, all you got to do is just plug this number into that equation. So off to the side here, you can use a graphing calculator, super handy, but it would look something like this if you're doing it by hand. 1 squared is 1, 2 times 1, negative 2 times 1 is negative 2, and then I add 4 and I subtract 5. Negative 2 plus 4 is negative 2, negative 2 minus 5 is negative 7, I believe. Or excuse me, sorry. Negative 2 plus 4 should be positive 2, and then 2 minus 5 should give you negative 3. Okay, that is your y coordinate for your vertex. It's going to be right there. So you plot that point. I'll change the color here. Plot the point 1 comma negative 3. Looks like it's right there. Now, your vertex is going to be one of two things every single time. It's either going to be the top of the frowny or the bottom of the smiley. So you ask yourself, what am I dealing with right here? Am I dealing with a frowny or am I dealing with a smiley? To determine if you're dealing with a frowny or a smiley, all you have to do is you have to look at your A value. If A is positive, it's a smiley. If A is negative, it's a frowny. And because that is a negative number, we expect this to be a frown. We expect it to go down from that point. Okay, so now we basically just have to start getting some points on our parabola here. And a really easy one to find is usually the y-intercept. Okay, the y-intercept is going to be where this graph crosses the y-axis, and it's always just going to be equal to whatever c is equal to. In this case, c is equal to negative 5. So I know that one of my points should be negative 5. But if I have negative 5 as one of my points, what do I also have? I have the reflection across the axis of symmetry. So 1 unit to the left, I have negative 5. 1 unit to the right, I should also have negative 5. Okay. Then it's always a good idea to try to get a couple more points. Remember the y-intercept we just calculated. It's negative 5. It's one of the things they're asking for. Try to get 5 total points. If you get one more, you can just reflect it. How about we plug in 3 into this equation and see what we get back? So it'd be negative 2 times 3 squared plus 4 times 3 minus 5. Might not be the prettiest thing in the world, but we'll have negative 18 plus 12 minus 5. Use the calculator if you need it. Negative 18 plus 12 minus 5 should give you negative 11. So if you're making your input-output table, what are the points we have right now? The first point we got was the vertex. It's at the point 1 comma negative 3. Other points we have right now is we have the point 0 comma negative 5. And we also have 2 comma negative 5. And the one we found up here is that when we plug in 3, we should get back negative 11. So that's a fourth point. And I could plot it. 3 comma negative 11 over here. But if I have this point, I'm able to reflect it across the axis of symmetry once again. 2 units to the right, I'm at negative 11. 2 units to the left, I should be at negative 11. Right here, connect your dots, and you should have your frowny.